Hey everyone, it's Justin again, and in this video we're going to be solving compound inequalities, then testing our solutions to prove that they work. Let's just get right into it with this example. Negative 3x plus 2 is greater than negative 10, or 2x plus 1 is greater than 13. Solving compound inequalities essentially consists of solving each individual inequality and then connecting those answers with the same identifier word. In this case, it's or. So we'll go ahead and write that down as part of the answer. So for the inequality on the left, we subtract 2, then divide by 3. Don't forget that multiplying or dividing by a negative automatically flips the inequality symbol. So this one came out to x is less than 4, or whatever the one on the right solves to. So for the right, we're going to subtract 1, then divide by 2. So our complete solution says x is less than 4 or x is greater than 6. So then what values of x would satisfy this compound inequality? Well, any values of x less than 4 or greater than 6. Since this is an or, any covered area here is a solution. The only values that wouldn't satisfy this inequality are in this red area here that wasn't covered. Values in this area wouldn't satisfy either inequality. So here's our next example. Negative 4x plus 6 is greater than negative 10, or x minus 5 is greater than or equal to negative 2. We'll go ahead and leave the or at the end for when we have our final answer. And for the inequality on the left, we subtract 6, then divide by negative 4, remembering to flip the symbol. And on the right inequality, we just need to add 5 to both sides. So our answer is x is less than 4, or x is greater than or equal to 3. To visualize our answer, we show all the values less than 4 and the values greater than or equal to 3. With or compound inequalities, any covered value is a solution, so that's every value. So instead of writing the solution as a compound inequality, we could just write that the solution is all real numbers, because there's no number that isn't a solution. For our next example, let's solve a compound inequality with and. Remember, this means any solution has to satisfy both inequalities, not just one or the other. So on the left, we start by adding 4, then dividing by negative 2, and we get that x is less than or equal to 8. And for the right side, we just add 5 and get x is greater than or equal to 1. So the solutions here have to be both 8 or less and 1 or above. As usual, let's visualize the answers with a number line. X needs to be less than or equal to 8, and x needs to be greater than or equal to 1. This looks like an all real number situation, but remember that with and, only the area covered by both inequalities overlapping is the solution. So that's this area here. Notice that both 8 and 1 have closed points because each one satisfies both inequalities. 8 is less than or equal to 8, and it's greater than 1, and 1 is less than 8, and it's greater than or equal to 1. Because our solution is all values between two numbers, we can condense our answer to say x is between 1 and 8. Remember, it goes low to high with x in the middle, so we write 1 is less than or equal to x, which is less than or equal to 8. That actually brings up a good point. Sometimes an and compound inequality is already written in the condensed version. If we separate this, it would look like this. The condensed version says negative 2 is less than 2x minus 6, and 2x minus 6 is less than 12. But if we look at both of the separated inequalities, we'd solve them using the same steps. We add 6, then divide by 2. And since we solved them with the same steps, we can solve the condensed form just by doing those same steps to the whole thing. Left, middle, and right sides. So to get x by itself, we add 6 to the left, middle, and right. Then we divide everything by 2, and we get 2 is less than x, which is less than 9. So we said that x has to be above 2 and less than 9. So our solutions are between 2 and 9. We exclude 2 using an open point, because if x was 2, then it wouldn't be greater than 2. And we use an open point for 9 because if x was 9, it wouldn't be less than 9. But any other number between 2 and 9 works. All right, last example. Negative 2x minus 4 is greater than or equal to negative 8, and x minus 5 is greater than or equal to 2. So for the left side, we're going to add 4, then divide by negative 2. And on the right, we add 5. So our answer says that x should be less than or equal to 2, and that x should be greater than or equal to 7. So our answer has to be both equal to or below 2 and equal to or above 7. There's no numbers that are less than 2 and bigger than 7. Our diagram has no overlap because there isn't a single number that could satisfy both inequalities at the same time. So I guess it's a good thing we graphed it, or we might not have realized that the actual answer here is no solution. Compound inequalities can be confusing, so make sure to play the practice game on our website.